mason jar.
That's the shine. Where is the full shine?
Well, it's going now.
Is it? Yeah. Hold on. Is there any shine in there?
Oh, we got some for you. If you're
A
brave
key?
enough.
Right now.
If you're brave enough.
No, we don't.
All right. Quiet on the set. No.
I thought Adam was the director.
No.
Oh, sorry.
I'm the off-camera commentary.
Producer. Okay.
His director's commentary before it's
Real
Okay.
life. In real time.
So, this is the brewery built by Motherlode and Hybrid Mojo. I guess we're here today to explain to you a little bit how it works. So first we have our 3 tanks, the hot liquor tank, the mash tun, and the boil kettle. They're each 55 gallons each, and we have brewed beers up to 1.080 specific gravity with the mash tun. The process basically starts in the hot liquor tank. You heat your mash water up to temperature, transfer it through this first pump.
What's in the mash?
Well, I haven't got there yet. Thanks for the question, peanut gallery. We're going to put our grain in the mash tun after
It's called
we crush
off-camera commentary.
it. Thank you. Anyways, so we heat our mash water up to temperature, transfer it with the first pump to the mash tun. After we have the water in there, we add the appropriate amount of grain. Let it sit in there for an hour. After that's done, well, while that's happening, we heat our sparge water up again in the hot liquor tank. And then we start to transfer from the mash with the second pump
Riveting, but I'm out of here.
up to the kettle. And then we turn the first pump back on and we sparge with the sparge assembly. So we're washing this is the sparge assembly we have created. It's got little tiny holes drilled in it to slowly add the water on top of the grain bed. You can see that. So what's happening here basically is the 2 pumps are synchronizing the water flow in and out of the sparge to rinse the grains of all the sugar and collect them into the kettle. So after it's all, so we're using these first 2 pumps to accomplish that. As you can see, there's 4 valves down here, and they're all actuated with, we're using Belimo actuators, typically used in HVAC applications.
Daddy.
So after we're done rinsing the grain, that process takes about 90 minutes. We have all of our wort at this point in the kettle, and we use our heaters. They're 5,500 watts each. We have 2 in the kettle. I didn't mention it, but we also have 2 in the hot liquor tank to heat the hot liquor tank up. We use that to bring the brewery to a boil, and then we boil for an hour, or however long your boil goes. And then we use the final pump to pump out of the boil kettle through the, this is our hop catcher, catches any hot particles before it goes in the heat exchanger. So we use the pump to pump through that, and through the heat exchanger, and then out. And hot water about 212 goes in, comes out about 80 degrees out of the heat exchanger. We're using just tap water to circulate the opposite direction as the wort. What else do you want to know?
Well, that's pretty good. So in terms of the controls, you got a high voltage side and a low voltage side, right?
Yeah, so as far as the controls go, here's our high voltage side, and we've got a 12 volt, it's not plugged in right now, so we don't have to worry about touching anything, a 12 volt DC, a 12 volt AC, and a 24 volt DC.
And so all the actuators went off 24 volt light, right?
All the actuators run off 24 volts.
And the pumps are...
The pumps are 12, and the relays are 12 as well. So these are our relays, 4 for each, 1 for each of the heaters, and then.
It's actually the control signal on the heaters, right? Is the 12 volt.
Yeah.
And then the actual outputs. Was it 120 or 240?
240.
Yeah, 240.
And then on the bottom side, it's a little messier. never got the chance to put it all together, but we have our brain here, which is the Arduino. also now named Beer Me. And we have our, these are our small relays for our pumps. And then we have our temperature sensor controls here. We didn't talk about those, but every vessel has, you can see on the front here, has temperature sensors.
And everything on here is just these clamps, right? These
Yeah.
tri-clamp. So that clamp comes off, and then you have something which you can put in. There's these fittings, right? And so the fittings got welded on with the. They had to be welded onto the drums.
Yes, we had they're called tri-clamp ferrules, and they were welded onto the drums by a stainless welder.
Who's bribed with beer?
Fried with beer. Interesting thing on the temp sensors is we start with analog. They didn't work very well. Definitely recommend going with digital sensors.
You know, with analog, the problem is just the calibration, right?
Yeah,
Digital
depending on
ones.
temperature, humidity outside, you could vary between 1 and 3 or 4 degrees on the temperature reading.
So your actual control panel is the PC, and then you have a separate electrical panel just for.
Yeah, so the electrical panel, we have a circuit, a 30 amp 240 circuit for each of the heaters. 1, 2, 3, 4. We have a GFI here that controls the computers plugged into, and then we have another breaker here that controls the control power for all the parts of the brewery.
And quite a severe looking
This is
extension.
our 50 amp cord cap that we use to plug the brewery in when we're using it. This panel is powered by 50 amps. If we were to want to use all 4 heaters at the same time, we would need to upgrade that to 100 amp.
All right. Well, actually, there's different receptacle for 100 amps.
We would need 2.
Oh, I see.
They don't make 100 amp
Yeah.
like that.
Alrighty. So I mean, it's pretty basic, right? So you have 3 tanks, and one of them just a boil. So comparing to like a 5-gallon setup, that left one's just a hot water heater.
Yeah, basically it's
The middle one's for doing the all grain, essentially, if you were coming from a 5-gallon extract brewery, right?
Mm-hmm.
And the right hand side is just what you would be doing actually in a 5-gallon homebrew
Yeah,
setup.
if you're just doing a 5-gallon extract setup, basically you would just have the one vessel and you would have it on your stove, you'd heat it up to 152 degrees, steep your grain, and then you'd heat it up to boil. But in this system, we're all grain, and so we have to have other vessels to steep and heat our water.
Now, for the switch to doing 3 times this size up, what's going to change?
It's going to be about the same, just on a larger scale.
I think you said a couple of pumps had to change out or something. Most of them have pretty beefy anyway, right?
We have the first pump, to go a little bit larger, is going to be small, but the other 2 pumps should be fine. If you're going to boil more, you want to add more heaters. So you're going to have larger, more relays, larger power panel, and more heaters in each of the vessels.
With the, I know that at the beginning the problem was the particulate in doing the recirculation. So this last tank can recirculate, right?
Yeah,
It's got
so
one
that-
valve which diverts some of the flow to the heat exchanger, because if you tried to divert all the flow to the heat exchanger, it couldn't cool fast enough. So it only does a portion of it, and some of it gets recirculated, right?
Well, so what it does is, at the end of the boil, we whirlpool for half an hour, which causes most of the particles to settle in the center in a cone. And so we drain off from the side. We have so you can see that our outlet from the kettle is here, and it's right on the edge. So we get this cone in the center, and we're able to drain all the wort off the side through the heat exchanger. So it just adds a step to the process.
So that that was clogging at the beginning, but then you had the false bottom, which you added.
Well, you can't see them right now, but they're inside. They're inside the mash tun, both of them actually.
So there's the heaters inside the boil, and you said it's in here, the false bottom?
Yeah.
There's 2 of them?
Both of them are sitting in there.
Oh, okay, there's 2 of them, so one here, one in the boil. And it's got a handle to lift it up, and then some little legs to keep it off the bottom, right?
Mm-hmm.
Yeah, and then just perforated sheet. All right, that's pretty much it, and that was the key to make it work. And then, final thing was the this tank that you got here.
Yeah, and so This is a stainless steel jacketed fermenter. The jacket is cooled by our 3/4 ton glycol chiller. A little oversized for the application, but it works pretty well. One of the things it allows us to do is our knockout time from cooling our wort to having it all in here is decreased by a significant amount because we can put our wort in here at 85, 90 degrees and use a chiller to cool it down to fermentation temperatures.
Previously, it was that thing over there, which has no temperature control whatsoever, right?
It's about
So.